We have one more way of solving systems that we're going to look at, and this way is called elimination. But first, if you look at this problem that I have here, I want us to do substitution. I want you to see why we have elimination and where substitution kind of has a tough time. If you look at this problem, we don't have any clean variables. We've got 2x, we've got 6y, we've got 3x, we've got 2y. There's a whole lot of non-clean variables, and so this is going to be a little bit tougher for us. I think what we should do is we should go ahead and solve for the y on the bottom. So we take negative 3x plus 2y equals 10. We move the 3x over. I'm going to solve for the y on the bottom again. So now I have 2y equals 10 plus 3x. Divide everything by 2. So then y equals 5, and then yes, we're going to have a fraction 3/2 x. Now I'm going to take that and I'm going to plug it in for the y on the top. So let's see here. If I take that, that goes in for the y on the top. So I have 2x minus 6 times 5 plus 3/2 x equals 19. So simplifying, I have 2x. Now I need to take that negative 6 and multiply it through. So I get minus 30. Minus, now 6 divided by 2 is 3, times 3 is 9x equals 19. Combine my like terms, I get negative 7x minus 30 equals 19. Add 30 to both sides. And negative 7x equals, what is that, 49? Divide by negative 7, x equals negative 7. Oh, I think so, yeah. And then now I have to figure out what y is, so I plug in negative 7 in right there. Unfortunately, if I plug in negative 7 there, it does not cancel with the 2. So let's see here, I get 5 minus 21 over 2, right, because we have 7 over 1. And then this 5 turns into 10 over 2. I get negative 11/2 for my y value. So my point is negative 7 and then negative 11/2. Alright, so substitution is possible with substitution, but it is kind of annoying. There are some frustrations with it, especially if you don't have any clean ones. Now, with elimination, by the way, your book calls this linear combinations. So if you see it saying solve with linear combinations, what they mean is elimination. And what our goal is to do is we want to actually wipe out either the x's or we want to wipe out the y's. We're going to eliminate them so that only the x or the y is left. Now, on this one, you'll notice I say use algebra blocks. So basically what I would try to show you with the algebra blocks is how you can actually clean out the x's and y's. But I think you guys can handle just learning this using elimination. Oh, solve the above equation. Okay, so what I'm going to do then, we're going back to this one here. I'm going to solve this one using elimination. So in order to do that, I need either the x's to 0 pair out or the y's to 0 pair out. So what I'm going to do is I'm going to take this bottom equation and I'm going to multiply by negative 1. And the reason I'm doing that is because the x's already have the same number. So if I multiply this by negative 1, then I have a positive 2x and a negative 2x and they 0 pair out. But if I'm going to do this legally, I need to multiply the whole equation by negative 1. So I do that. I have negative 2x minus 2y equals negative 10. And then I'm just going to write down the top equation again just to make sure I have it all there. And now what you'll see is that the x's completely wipe out. I have positive 2x and negative 2x. Here I have y equals, and then over here I get 3. So apparently I'm thinking I must have made a mistake somewhere above, because I think this is the same problem as what I just did. Nope, it's not. Okay, good. Alright, so then now that I have y equals 3, I can plug that into any of the equations. I could pick the top equation, I could pick the bottom equation. It doesn't matter which equation you pick. Sometimes some are better than others. I'm just going to use the top one. So plus 3 times y is 3 equals 13. And then I have to do my math. 2x plus 9 equals 13. Get rid of the 9. So 2x equals 4. Divide by 2. X equals 2. So my point that I just got was x is 2, y is 3. Alright, so now here is the problem we had from before. You'll notice it's going to be a little bit different here because Nothing, I mean, I don't have any of the same numbers. My x's, I have a 2 and a 3. My y's, I have a 6 and a 2. So they don't just automatically cancel out. What I'm going to do, I think, it's easiest to cancel out the y's. So I think I'm going to just take this bottom one, and if I multiply by 3, then I'll get a 6y, which will cancel with a negative 6y. So I get negative 9x plus 6y equals 30. And then I'll rewrite the top one. Okay, it's good for you to double check that you multiplied everything and that they actually zero pair out. So my y's cancel out. Here I get negative 7x equals 49. Divide by negative 7. So x equals negative 7, just like we got with substitution. But do you see how much easier it was? We didn't have those fractions to deal with. Now I'm just going to take that negative 7, and I think I'll just plug it in the top one here. So I get 2 times negative 7 minus 6y equals 19. Get negative 14 minus 6y equals 19. Add 14 to both sides. Negative 6y equals 33. Divide by negative 6. So y equals, let's see, 3 goes in there 11 times, 3 goes in there 2, so negative 11 halves. So my x value is negative 7, my y value is negative 11 halves, just like we had at the top when we did substitution. So you'll see it's actually easier. Elimination is the easiest one to use. It would be the one I would choose every single time if I needed to do solving a system. Alright, so now it's just a chance to practice. What I want you guys to do is you should pause this, do this problem, and then see if you get the same thing as me. I am going to cancel out, I think I'm going to cancel out the x's. So to do that, I'm going to multiply the top one. If I'm canceling out the x's, I want them to both be 10. I'm going to multiply the top one by negative 5, and then the bottom one by 2. Make sure you have one positive, one negative. So now I have negative 10x minus 15y equals positive 5. And in the bottom, I'm going to have 10x plus 10y equals 30. My x's cancel out completely, so I get negative 5y equals 35. Divide by negative 5, y equals negative 7. Alright, so if y equals negative 7, we're going to have 2x plus 3 times negative 7 equals negative 1. So 2x minus 21 equals negative 1. Add 20 both sides, add 21 both sides, thinking ahead. So 2x equals 20. Divide by 2, x equals 10. So we get 10 comma negative 7 for your answer. Here's another one. Now, again, you should pause and try this yourself. And why don't we all plan on canceling out, let's cancel out the y's. So everybody try to cancel out the y's. Okay, so to cancel out the y's, I'm going to take the top one, I'm going to make them into 24, so I need to multiply it by 2. And the bottom one I need to multiply by 3. And remember, they're already positive or negative, so we don't have to worry about that. So we get 14x minus 24y equals negative 44. And we have negative 15x plus 24y equals, let's see, 1242. Alright, now I'll combine them. The y's cancel out. We get negative 1x equals negative 2. And so that means x equals a positive 2. Now if x is a positive 2, I'll go ahead, I'm going to use the top equation for that. So I get 7 times 2 minus 12y equals negative 22. So 14 minus 12y equals negative 22. Subtract 14. So negative 12y equals negative 36. Divide by negative 12. Y equals 3. So x is 2, y is 3. Alright, not much left. Looks like I just have, 2 examples left. Alright, so let's all work on, let's cancel out the x's on this one. So if I want to cancel out the x's, I need to multiply by negative 2. So we have negative 2x plus 4y equals negative 6, and a positive 2x minus 4y equals 7. So my x's cancel out completely, but so do my y's. And so on this side of the equation, since there's nothing left, I put a 0. And then over on the right, I get negative 6 plus 7, I get a 1. And so what happened is x and y are completely gone, and I get something that's not true. 0 is not equal to 1, which means this is a no solutions problem. If it's a not true statement, you need to say no solutions. Okay, now if we go down to this one, why don't we cancel out, let's see here, let's cancel out the, x's. So if I cancel out the x's, I want these to be 30, so I multiply by 5 on the top, and then on the bottom I'm going to multiply by 2, and they'll cancel out. So I get 30x minus 50y equals 60, and on the bottom I get negative 30x plus 50y equals negative 60. And so my x's cancel out completely, my y's cancel out completely again, so this side's going to be 0 equals, and then my 60's cancel out also, so that equals 0. So you'll notice that 0 equals 0, that means all solutions. So the moral of the story is, if you get an answer like the top where it's not actually equal, so you get something that's not equal, this could happen in substitution or elimination, then your answer is no solutions. If you get something like on the bottom where 0 equals 0 or 5 equals 5 or something that's true, then it's all solutions, and that can happen whether you're doing elimination or substitution.